Welcome to today's virtual classroom. I'm Tim Curran, your instructor. Today we're going to be doing four things. In our first lesson on differentiation, we're going to be first looking at finding derivatives from first principles. Today we're going to talk about average rate of change. It's a part of quantitative measure. The average rate of change is the overview of the effect that one variable has, the independent variable, on a second variable, the dependent variable. The independent variable is graphed here along the x-axis, and the dependent variable here is graphed along the y-axis. So we're looking at the effect of changing x has on the change in y. To find the average rate of change of y, it's necessary to have an initial point and an end point as x increases from x1 to x2. We need an initial point and an end point. The average rate of change from A to B is simply the slope of this green line, which of course is y2 minus y1 over x2 minus x1. We see here that velocity can measure the average rate of change. We see here that velocity can be seen as a measure of the rate of change of displacement. Velocity average is the change, that triangle means delta, change in displacement, or delta displacement over delta time. Change in displacement over change in time is the average velocity. We can also talk about the qualitative aspects of change. An increasing function means that as x increases, y increases. A decreasing function means that as x increases, y decreases. And a stationary function means that as x increases, y stays the same. So now let's talk about the differentiation process. We're going to be finding the instantaneous rate of change. You see that this green line between the points A and B represents the average rate of change between A and B. If point A has an x-coordinate of x1, then the y-coordinate is f of x1. So this point would be x1, f of x1. And if point B has the x-coordinate of x plus h, then point B has the coordinates of x plus h, comma, f of x plus h. So we have 2 points. Point A is point x, comma, f of x. And point B is x plus h, comma, f of x plus h. Now that's the average rate of change. What happens as we move x plus h towards x? In other words, what if we shrink h closer and closer to 0? The distance between A and B on the x-axis is going to be going from h down to 0. So we're going to move point B closer and closer and closer to point A. And that right there is the heart of the limiting process. We're going to limit h going towards 0. We'll see that in the next slide. Here I've taken the last picture we had and I blew it up. Here I took the last drawing we had and I blew it up with a magnifying glass. You see, there's a magnifying glass, and here is our curve and our points A and B, and they are still separated by a distance h. But you can see that the distance h is shrinking. Well, I'm bringing B closer and closer to A. So if I bring B all the way this close to A, and I look at it under a magnifying glass, I can see that my distance h now, if this is x plus h, my distance h is just this tiny distance here. That is the heart of the limiting process, because eventually they're going to get so close that they'll be indistinguishable, and our green line, which is our secant, which is the average rate of change between 2 points, becomes our instantaneous rate of change, and that is what we call differentiating. The gradient function is an expression that allows us to find the instantaneous rate of change at any point on the curve. The gradient function is also known as the derivative. What we're doing here is finding the derivative from first principles. We are talking about finding the derivative from first principles, and again here is this drawing. If I have my curve f of x, my point x, comma, f of x is a, b is x plus h, comma, f of x plus h. The average rate of change through the points a and b is the green line, which is the same secant. As we take the limit as h goes to 0, we move b closer to a. Eventually we get a tangent line. That is the derivative. This is taking the derivative from first principles. We see the rate of change is the limit of h goes to 0 of f of x plus h minus f of x divided by h. Again, this is finding the derivative from first principles. It is the gradient function, a new function that will give us the gradient or the tangent, the slope of the tangent, anywhere on the curve f of x. When we find the derivative, we are finding the slope of the tangent. We're finding the slope of this red line. That's what the derivative is.